Hey, so my name is Mac Welsh, and I am a student here at Clemson in the grad program with CSM, and here's my final project for energy efficient measures. Start off with to do a little bit of overview about the building. According to BOPT, it's a little bit over 3,100 square foot. It's got 4 bedrooms, 2.5 bathrooms. It's for a family of 5, the Burgett family. It's in Clemson, South Carolina. And it's also got a little bit of updates. I know the HVAC system was updated. I think the roof was too, kind of looking at some of the discussions. Um, and then obviously some appliances over the year as well. So some strengths and weaknesses with the building. Really a big strength is use of windows. It lets in natural light. Don't use electricity as much if you have natural light, so it's a good way of saving some energy. The landscape as well. It does have a lot of trees, so it provides a lot of shade, and so you don't have um, the house may be as hot during the summertime, so maybe it helps out with some of the cooling costs. And also, there's just a lot of vegetation around the house, so it can absorb some of that storm water, rainwater, stuff like that. Another thing is the insulated building envelope, which is kind of basic. It's code to have that, but it really does help keep the elements outside of the house and keep the cold or hot air out, and just helps with that. Helps with cooling costs and stuff like that. So another thing about this house is there are a couple weaknesses. So the position of the house really is a weakness. It's facing south, and so um, if you want to capture some solar energy, you really want to be facing east to west. And so if you're going to use a PV roof, it's really not the best position of a house. You can't really change that, but you can change the position of a PV roof or solar panels. So it can be fixed, but it is definitely a weakness. Windows and doors are a weakness. They're not as efficient. Looking at their U value, which is just kind of saying how efficient they are with letting heat gain and stuff like that in. They're really not as efficient. I know the house is a little bit older, so maybe they haven't been updated, but definitely can affect some HVAC costs. And then the water heater, having a 50-gallon tank with 5 people in the house, it takes a lot of energy to heat up water, and so definitely is another weakness with the house. Moving on, some energy efficient measures that I'll be talking about is a PV roof, a radiant barrier, tightening of the envelope, low E windows, and some lessening load, kind of unplugging appliances, stuff like that. I'll go into more detail in a minute or two. So a little bit of the analysis of the house. Took about 1457 kilowatts per month. That was about the average, which cost about 150 bucks. Total is about 17,486 kilowatts, and it costs about 1798. The high was in February, which used 3,332, or excuse me, 3,300. I can't talk. 3,032 kilowatts, and the low was 809 kilowatts. So the high was in February. It was during a month that snowed twice, and so having kids, I'm assuming they were probably in and out of the house a lot more. It is a little bit lower temperatures than we're used to as well in South Carolina. So that's kind of an explanation for February. In the fall, we really see a decreased usage in the HVAC system. Maybe there's more natural ventilation. It does have more moderate temperatures, so you are using it less. And so we did see a decrease in the spring and fall months, and then an increase in the winter and summer. Obviously, during the winter, you're going to be using the heat more, and in the summer, you're going to be using the air conditioning more. So another thing about the energy model is the BOPT model. So we use this BOPT model. It's a software created to design and simulate buildings. And it really is meant to create a net zero energy building. And so that's kind of the goal. It uses a lot of PV roofs and solar panels and stuff like that. And so what you can do is you design a building using different kinds of space, living space, garage, finished attic, different stuff like that, make a building. And then you choose some of the parameters, some options with energy efficient measures and stuff like that, different characteristics of the building. And then you can put some local info in, maybe some tax incentives, maybe some different things like where it's located and stuff like that. So you really put that in, and then you can see some output. So it really shows you how much energy it used, at what cost, and so it really does show you how the building will save energy. Some strengths of it: it is easy to use, and that you don't have to have an extensive knowledge to use it. Some weaknesses are it is a little too simple. It doesn't really have inches. Like you can't really use an exact measurement. And then a lot of the assumptions are kind of basic and kind of generic, and so you do have to make some generalizations about the building, which can kind of make it inaccurate at times. So some assumptions that I made the back porch roof flat. You can't really do two different kind of roofs on the first level, so I did that to kind of keep it as accurate as I could. The room over the garage, I put as finished attic space. It kind of just seemed the most accurate use of the space, just kind of the description of it. It might not be really considered attic space. I'm not exactly sure, but I would consider it attic space, and for this model, I think it was the most accurate description. I had a neighbor at 15 foot on the right. Um, from pictures, you can kind of see a house, and so I just kind of assumed that there was only one on the right for 15-foot distance. And it might not be exact, but again, the most accurate option. Also, I assumed the use of natural ventilation for cooling months only. I'm assuming they're not opening windows up and stuff like that during the summer or winter and stuff like that 3 days a week. And then I also just kind of assumed a standard schedule for appliances as well. So comparing some of the actual costs and the BOPT costs, the actual was 17,487 kilowatts per hour, and then the simulated was 31,653 kilowatts. And again, I think that a lot of the causes of this were just kind of some inaccuracies that were caused by the design. You can't be exact in the assumptions as well. So there are some definite causes for that difference. And so going into some of the energy efficient measures that I use a PV roof. It absorbs solar energy, converts it to electric, uses a grid system. It helps power the house and light the house, so you don't use as much light. Got the price, so it's price per watt, and if you use a 7 kilowatt, 7,000 watts, so you just kind of multiply that through. There is a tax incentive as well, so you do get a reduced cost, and there's a yearly incentive as well. So you do factor that into the savings that it has, and so then it will be calculated to pay off in about 4.14 years. The next one is a radiant barrier, and so what this is a double-sided reflective, pretty much aluminum foil, and it's been recommended a lot. I've actually heard about it a little bit being used, so I was really interested in this. So essentially, you just put it in the attic space, you hang it from the rafters, and it really just reflects that radiant heat coming in from the roof, and so it kind of directs it out of the house and not into the attic, which affects the cooling costs. It keeps it cooler. And so with this, I did calculate the roof area with a slope factor. I think it was 8 to 12. And so with that, it's going to be a little bit different than just a flat area, obviously. And then those costs per square foot, multiply that through. And then you just get the savings. It does save about 135 kilowatts a year. And it says it's going to take about 30 years to pay back. Again, I think this is kind of where the model was a little inaccurate from my experience, but just kind of went with it. I tried to tinker around with the model a lot, but nothing really helped. But so I do think that was a little bit inaccurate, but it's still a effective energy efficient measure. Another energy efficient measure I used is a rigid insulation, and so it just tightens the envelope by reducing the amount of air leakage and outside temperatures affecting the indoor temperature, and it just reduces the HVAC cost. There isn't any rigid insulation on the house right now, per the plans. It does say that does have vinyl siding, and vinyl siding with rigid insulation is very effective. And it's also really easy to put up. It can be a little labor intensive, but It's not like installing something very complicated. So again, price per square foot, total cost multiplied by with a installation cost as well as a square footage. Using that for the plans, got about $3,269, and then you just get the savings per year, and then you divide that through um, and get the savings. And it would take about 15, 16 years to pay back. Again, I do think that's a little high, but using the information that I have, that's what I got. Also, unplugging and lessening loads. So unplugging appliances, having timers and stuff like that can really reduce vampire energy costs. And so that's just energy costs that are being used when things are plugged in but not actually being used. And so that really can affect a house. And you might not think that plugging in a charger and keeping it plugged in really affects the electricity bill or energy, but when you combine everything together, it does actually make an impact. And so a big thing with this is that it can be very low cost. It can be free if you unplug it yourself, and which is it's very practical this way. You can also buy timers that are very cost efficient as well. And it's just really a simple way of doing it. And over time, you're going to consistently reduce the energy of electricity that you use. Um, Low E windows, so they reduce the solar gain and heat from coming in the building. There's a special coating. There's multiple different ways to kind of do it, but there's a coating that kind of reflects some of that solar heat away from the inside of the house. And there's also can be gas, sometimes argon, and in between the different panes, and that really kind of slows down the heat process, but also can also kind of push that heat away from the inside of the building, and it just reduces some of the heating costs. So again, you got a price per square foot of window. You multiply that for your square foot. Kind of using one of the assumptions I made was 325 foot of windows. Multiply that through. Then you get the savings. It did save about 1427 kilowatts, and then multiply that by a yearly saving cost. It would take about 46 years to pay off, which again I think is a little bit inaccurate, but that is what the model's kind of telling me. Also, there's some recommendations. So I would definitely recommend the PV roof. I think that is probably the most efficient and payback efficient as well. Low E windows, I would definitely update windows at some point. I think that it's a good way of just keeping the house energy efficient. And something else that I would also recommend is unplugging appliances. This is really simple, it's really practical, low cost, low payback, and something that you can do. It's not going to save you big bucks, but over the years, consistently, it will save you money. And the low E windows combined with this, I know that the payback was a little higher than I was expecting, but I do expect that number to be a little bit lower than what this model showed. And then other ones, the radiant barrier and then tightening of the envelope. They're both good options. Tightening of the envelope would probably cost a lot of money. And so that's just kind of a risk that you take. And the radiant barrier as well, there is a big payoff as well and payback time. So maybe it's not the best option, but all good options if you want to start saving some energy and saving some money. This is my presentation, and I will talk to you guys soon. Thanks. Bye.